Hello everyone, this is Noor. I'm back with a new video. Today we will be speaking about these graphs that normally get medical students really worked up, especially the ones who are writing Usmle step 1. So I will try to make it as easy as I possibly can for you guys to answer your questions without using much of your brain energy. Okay, so let's get started. So the first thing that I want you guys to do is whenever you see a graph like that where you're given the blood pressure on y-axis, firstly note that the one with higher blood pressure is going to be your systolic blood pressure and the one with the lower blood pressure is going to be your diastolic blood pressure. Whenever you see graphs like that, the first thing that I want you guys to do is write down alpha 1 and beta 1 here and alpha 1 and beta 2 here. So for our purposes, we will only concentrate on alpha 1, beta 1 and beta 2 activity. We will not take into consideration alpha 2 as it does not have much to do with our graphs here. So we will ignore alpha 2, alright? What I want you to understand is, firstly, alpha 1 causes vasoconstriction. Okay? Vasoconstriction can increase total peripheral resistance and it can increase preload. So because of increase in total peripheral resistance, it will increase your diastolic blood pressure, and because it can increase preload, it will increase your systolic blood pressure. So what I want you to get out of this is, whenever there's increased alpha 1 activity, there's going to be increase in both your systolic blood pressure and your diastolic blood pressure. So it has a direct relationship. Alright, now let's talk about beta 2. Actually, let's first talk about beta 1. Okay, so what does beta 1 do? Beta 1 increases your heart rate and beta 1 increases your cardiac output, right? By increasing your cardiac output, it will increase your systolic blood pressure, and by increasing the heart rate, it will increase your diastolic blood pressure. So again, all in all, what we're saying is, when there is increased beta 1 activity, there will be an increase in your systolic blood pressure and there's going to be an increase in your diastolic blood pressure. So both alpha 1, beta 1 increase activity will increase both systolic blood pressure and diastolic blood pressure. I think it would be easier if you think of it that way. Beta 2 is complete opposite of alpha 1. It causes vasodilation, and because of vasodilation there will be reduced total peripheral resistance, so it will reduce your diastolic blood pressure. So all in all, increased beta 2 activity will reduce diastolic blood pressure. It has an inverse relationship. I hope that is clear. Now let's dive down into your graphs. So we said if there's increased alpha 1 activity, there's going to be increased systolic blood pressure. If there's going to be increased beta 1 activity, there's going to be increased systolic blood pressure. So 1 plus 1 is equal to 2. They will both cause an increase. Alright. Here is the opposite. It's going to be, if alpha 1 increases, it will increase the diastolic blood pressure, whereas if beta 2 increases, it's going to decrease the diastolic blood pressure. So both of these, they go against each other. Alright, they go against each other. For example, minus 1 and plus 1 is equal to 0. If they're exactly equal to each other, then they will cancel out the effect on the diastolic blood pressure. Okay, so now that we have that understanding, let's talk about norepinephrine. This part is the only part that I think medical students need to memorize, because other than that, everything is very easy. Norepinephrine. So norepinephrine has an effect on beta 1. It has no effect on beta 2. Okay, so let's just write down it in a way that we understand. Alpha 1, we said we are not taking alpha 2, beta 1 and beta 2. So effect on alpha 1, effect on beta 1, no effect on. But epinephrine has an effect on alpha 1, has an effect on beta 1, has an effect on beta 2. Now the important thing here is that I need to understand that the effect on beta 2 is more than the effect on alpha 1. Why is it important for you to understand here and understand this here is because we know that they both work in opposite direction, right? So if there's going to be a larger effect on beta 2, so we will see vasodilation because it will cancel out alpha 1. And if we see an increased effect in alpha 1 compared to beta 2, we will see vasoconstriction. So this is important for you to understand because they work in opposite directions. Alright, now isoproterenol. Now the important thing here again is that it has an effect on beta 1, it has an effect on beta 2, but has no effect on alpha 1, right? On alpha 1, right? Now let's go back to our picture and you will be able to answer the questions very easily. Okay, now here's the thing. We said that norepinephrine has an effect. Firstly, write down alpha 1, beta 1, alpha 1, beta 2. That's the first thing we do. And now we know that norepinephrine has an effect on alpha 1 and has an effect on beta 1, has no effect on beta 2. Okay, now we know that. An effect on alpha 1, an effect on beta 1, we said when both increase, it leads to an increase in your blood pressure. So we see this increase in blood pressure, right? So increase will cause increase systolic blood pressure. Now let's come to this line right here. Now we have alpha 1 and beta 2. Now we have to look at it because they work on opposite direction. We said there is no effect on beta 2. If there's no effect on beta 2, that means there is unopposed alpha 1 activity, and alpha 1 causes vasoconstriction, which increases your diastolic blood pressure, right? So we will see an increase in your diastolic blood pressure. Good. And whenever there is an increase in your blood pressure, that is sensed by your baroreceptors, and there's going to be a reflex action by your vagus stimulus, and we will have a reflex bradycardia. And here, because there is no beta 2 activity, we have unopposed alpha 1, which increases the total peripheral resistance. Now let's move forward. Write down alpha 1, beta 1, write down alpha 1, beta 2. Now what do we know about epinephrine? Okay, we said that epinephrine has an effect on alpha 1, right? Has an effect on beta 1, right? And has an effect on beta 2. So that means it has effect on all three receptors that we're taking into consideration here, right? But the important thing was that it has higher effect on beta 2 compared to alpha 1. Alright, let's get to it. Alpha 1 has an effect, so increase alpha 1, increases systolic blood pressure. Beta 1, increase in beta 1 activity is going to cause an increase in systolic blood pressure. So we see this increase. Okay, just follow these arrows here. And now here is when we have the complication, because we said that beta 2 activity is more compared to alpha 1. Okay, so this alpha 1 get cancelled, but we still have two arrows going up, and we said beta 2 has an inverse relationship with your diastolic blood pressure. So increased beta 2 will lead to vasodilation and hence reduction in your total peripheral resistance, therefore causing a reduction in your diastolic blood pressure, which is what we see here. Okay, Now let's talk about heart rate. Okay, we said that whenever there's an increase in mean arterial pressure, which is what we see here, there should be it should be sensed by the baroreceptors and there should be reflex bradycardia. Yes, that is what happens, but here what happens is that we do get reflex bradycardia, but the effect of epinephrine on beta 1 is so high that it overcomes the reflex bradycardia, and what we see in return is increased heart rate. Okay, and since beta 2 is going to be more than alpha 1, we will see the reduction in your total peripheral resistance. Good. Let's move forward with isoproterenol. Alpha 1, beta 1, alpha 1, beta 2. Okay, so isoproterenol, we said that it has almost little to no activity on alpha 1, has an effect on beta 1 and has an effect on beta 2. All right, no effect on alpha 1, so but it still has an effect on beta no effect on beta 1, alpha 1, but it still has an effect on beta 1, right? So we will see this increase in systolic blood pressure. All right, now here let's come to it. No effect on alpha 1, but we still see beta 2 activity, which causes vasodilation. Vasodilation causes reduced total peripheral resistance, unopposed, because no alpha 1 activity, right? So there's going to be major reduction in your diastolic blood pressure, which will bring your mean arterial pressure down. Once this drop in blood pressure is sensed by baroreceptors, there's going to be reflex tachycardia. Not only that, because it also has an impact on beta 1, there's going to be increased heart rate due to the beta 1 activity. So whenever you see beta 1, remember, whenever you see beta 1, there's going to be increased heart rate due to the beta 1 receptor activity. All right, so I hope I've made this clear enough for you guys. If you need more input on it, or if you think that something is not clear and I should make it more clear, please feel free to comment in the comment section below. I'll be waiting for your responses. Thank you for watching this video, and I hope this brought some sort of mental peace to you guys. Thank you for watching.